and welcome back to another episode of the Cables to Clouds podcast. My name is Chris Miles at BGP Main on Blue Sky. Joining me as always is my ever happy and gleeful co-host Tim McConaughey at Carpe Diem VPN on Blue Sky as well. Today we have a very special episode for you today. So we've obviously been talking a lot about AI in this podcast, sometimes when we want to, sometimes when we don't want to. Luckily today, this is a very specific use case that we do want to talk about. So we have a guest joining us, Sam Zamanian. Did I get that right? Sam Zamanian, who is currently a principal advisory director at Infotech Research Group. And oddly enough, our first actual Australian resident that we've had on the podcast, aside from myself. So this is a big day for us. We've had Peter on here a few times, but he's since flew the coop, so he doesn't really get to count. But we have an interesting topic today. We're going to be talking specifically about cloud and infrastructure selection for your AI workloads and how to appropriately do that. Sam's been doing a lot of work in this space, so we thought we'd bring him on to have a discussion about it. So Sam, I'll shoot it over to you. Can you tell me a little bit about yourself, who you are and what you do?
Yeah, sure. And thank you for having me. As you said, my name is Sam Zamanian, and I'm a principal director with the Infrastructure and Operations Advisory at Infotech, which is a global research and advisory firm. And prior to that, been around the IT industry for 20 plus years. I come from application background, and then I moved to architecture, and that's where I spent most of my recent career at, in various capacities, application solution architecture, and a little bit of enterprise architecture as well. And that was followed by spending a couple of years doing consulting for a global system integrator. And with my architecture journey has been predominantly in the financial services space, and cloud has always been one of the major areas of focus there. I've seen lots of moves, shifts, and evolution, both from the CSP side, but also as well as the industry. That's fast forward to my current role, research and advisory, and I've had the opportunity to do a bit of research on how to make sense of infrastructure and AI workloads in particular, or vice versa. And we can, roll this topic, and I'm hoping that people, will take away some insights from this podcast.
Yeah, absolutely. Well, thanks for joining us. And let's not waste any time. Let's hop right in. So, like I said, we want to talk about, cloud and infrastructure selection for specific AI workloads that you want to run, right? So I think we probably need to do a little bit of level setting. So first, let's kind of talk about the lay of the land and get an overview of what AI workloads is, right? Obviously, there's a big commotion right now these days around AI itself, right? But AI and ML have been around for many years, right? This has been a very prominent thing, specifically in cloud, for quite some time. So let's kind of understand the lay of the land. Like, what are AI workloads that you could run either on-prem or within cloud?
AI generally comes down to three stages from a workload perspective, and people already know this. There is data prep or data work that involves bringing data from different places in various shapes and sizes, and then the data then will have to be structured, refined, cleansed or cleaned up, making sure that irrelevant entries are removed, and that's becomes meaningful and relevant to the next step, which is training. That is the foundation of what AI does. The data then is used to develop AI models, and the model will learn patterns and behaviors and relationships from data. And then the next step, which I call it production mode, is where the model gets deployed to support the use case or application in question, and then uses the patterns that it's learned to make predictions or decisions based on unseen new data. So these are three categories of, or three steps of workloads that they come under one umbrella of AI workloads, and that gives us a lot of leverage to be able to, make decision or, to drive the conversation around the selection of cloud/infrastructure for AI, and gives us lots of opportunities to optimize for each of these specific categories.
Right. Okay.
Are we talking about basically like high performance compute workloads? Is that basically what we're talking about? Where we're talking about chunking huge amounts of data and doing an ETL, extract, transform, load type of operation? Is that what you're talking about?
Yeah, well, if I take the same breakdown, and we can go through them each by each. For data step, like you said, there might be HPC involved to structure data, but we need a scalable storage and flexible storage. Flexibility is a key here because data comes from different shapes and a variety of formats. Scalability is important from a storage point of view because we want to be able to move data around pretty quickly and efficiently, and you need sufficient network bandwidth there as well. For training, HPC becomes critical in the sense that we need a compute powerhouse that supports parallelism. And why parallelism? Because we're dealing with vast and significant amount of data and super complex calculations. And parallelism will make it possible to train data in a timely fashion.
Right, like hyper-threading, basically.
Yeah, correct. And there is the classic HPC, and we can get to this. And there is the AI, or the next evolution of HPC, which is more appropriate for AI, and thinking about AI accelerators. We can get to that discussion as well. And for inferencing, and that's the interesting part, you may be able to get away with general infrastructure unless you're dealing with real-time use cases such as mission-critical applications. But then the evolution from predictive ML/AI to generative. I don't know if I mentioned that from a different perspective. There is predictive AI, which enables people to make decisions, make recommendation, and doing forecast. And there is generative AI, which is around generating content, and
Right.
the latter has shifted the game and raised the bar for both training and inferencing from an infrastructure standpoint, and resource consumption has become a critical challenge as you move from classic AI ML to generative AI.
Right. So, I guess maybe kind of just a dumb question, but in that particular concept of kind of traditional AI ML workloads versus Gen AI, is there any significant difference from an infrastructure perspective? What needs to be accounted for in either one of those?
Yeah, the short answer is there are a lot, and just to give you an idea, in the generative AI we talk about large language models a lot, which wasn't the case with classic AI, and it can take between a few months to a year to train a large language model. That's the ballpark. Of course, not every use case can be as aggressive as that, but that's technically the world that we are at. And Microsoft used a supercomputer for OpenAI, Microsoft/NVIDIA, and that took about a couple of weeks, if I'm not mistaken, that otherwise would have taken a year just to train GPT-3 models.
Yeah.
So that's the scale that we're talking about here. Also, from inferencing point of view, there is a challenge of how you can load a large language model efficiently into memory, how you can distribute your AI models across different GPUs, across different nodes, and it'll become a combination of system design and infrastructure, in a way that your infrastructure choices will dictate some of your design principles and vice versa. You would have to think about traffic management, for example, with Gen AI a lot more aggressively than classic AI ML. With large language model, we need to think about caching from an inferencing point of view,
Right.
which wasn't a challenge back in the classic AI ML days. And also from infrastructure, GPUs and other types of accelerators are highly demanded. And there is a supply shortage and bottleneck around that, which has never been the case before. So
Yeah.
the game has been taken to the next level.
I'm just curious because what we just talked about being the large amount of resources, the infrastructure requirements, and everything that do you think? And I know it's really early now, and I don't know if you've had a chance to look at it at all. But what do you think about the DeepSeek thing, about what they're saying about being able to do essentially a lot of the stuff that these LLMs are doing with a fraction of the resources? So do you think there's any accurate truth to that, or is it embellishment from the?
I always think that optimization has been one of the challenges, but we got better and better at it. There's been this notion that when you deal with AI, you got to go with premium resources. And that breakdown that I just described would help you optimize, but there is tons of other opportunities to optimize. Now this DeepSeek is like 2 days old, at least.
Right.
We haven't got that much information, but just from a cost perspective, the cost of running a GPT-4 would be around $100 per million tokens.
Tokens, yeah, I saw that.
And the other one is, I think, $7 per million tokens. That's the difference. We'll have to wait and see how that will come about. But again, there's tons of opportunities to optimize.
Yeah, without hardware.
Yeah, correct, exactly. But with cloud, with virtualized hardware, the key part is to break it up and understand what those sweet spots are, and that would be heavily use case driven, as opposed to infrastructure driven decision.
Right. Okay. So yeah, I think that's a relatively good segue. So I feel like on this podcast we obviously are very cloud centric, right? And we talk about cloud each and every day in our day jobs as well. So we kind of get lost in the sauce, so to say, and we understand kind of the implications on why it's easy to do things in cloud, especially when you need specific things like resources for workloads like AI. But let's kind of go back to the origin of that and maybe talk about the conversation of doing something within cloud versus doing it on-prem, right? And what are some of the common decision factors that would come in when you want to choose doing this in the cloud versus on-prem?
Yeah, and that's always an open question. You cannot start with cloud, even though you can be skeptical about choosing cloud for your workloads. And before I get to that, I'd like to clarify two things. One is that the factors that drive cloud versus on-prem aren't unique to AI. They still apply to other non-AI, like general enterprise workloads as well. It's just that they may matter more with AI, just because the the impact of getting them right may be larger.
Right.
And the second part to that is that the cloud means different things to different people. If I'm in DevOps, then I think of cloud as a bunch of ready, like pre-built, readily available tools that they can just start with. If I'm in the line of businesses space, I'll see the CRM application, SaaS-based CRM application as a cloud capability, and that really is. If I'm an architect, I probably think about cloud as a cloud-native architecture. And for sure, if I'm an infrastructure person, I see cloud as a destination or a hosting mechanism. And AI is no different. It's a cross-functional capabilities. We still need MLOps. We need to think about infrastructure. We need to think about how you embed your AI solution in the application. Well, at least from an AI point of view, the only reason that I would use cloud or recommend cloud, let me rephrase it to the only time that I think that cloud would be chosen is the convenience factor. If I'm a beginner in the domain and I want to get something quickly up and running, I would start the cloud. Yeah. Because of that becomes a low friction option. I don't have to think about HPC procurement, because that tends to be, from an on-prem point of view, that tends to be cumbersome, slow, and complex. I don't need to deal with supply issues. I don't need to deal with massive upfront investments, and of course the skill set. So if I need to start with tools, then my only choice becomes cloud. That doesn't mean that that's the right answer, but that might be the right answer now.
Right, like with a lot of apps, right, where you'll prototype in the cloud, you'll figure it out in the cloud, and then you buy the, some people, especially if it's a 24/7 type of workload, which this could certainly be, you'll figure out the app, figure it all out, and then bring it back on-prem, and at that point you know what to procure, you know what the requirements are and everything.
Yeah, absolutely. And that's the convenience factor. It's convenient to start with cloud, and then we can figure it out later. Although from an on-prem point of view, I think there are two reasons that hold people back from choosing cloud. And one is predictability, both from a performance, definitely from a cost perspective, because the pay-as-you-go nature will going to create a lot of variability surprises from that perspective. But again, only for AI or only for HPC type workloads, also from a performance point of view as well. Because cloud, potentially the multi-tenancy aspects to it can lead to performance fluctuations. Although I haven't heard many stories around that, being the cost, the default of the CSP, but that's technically possible. And the other side to go on-prem over cloud is controls.
Of course.
Again, there's a classic one around data and security, but there is also AI specific one, which is around customization. Cloud would give you little opportunities to do deep customization, and by which I mean there might be cases, and this is again heavily use case driven, that you need to align your hardware choices back to your workload, and that gives you a lot of leverage to optimize from a performance point of view. You don't get that from the cloud, because we're dealing with a pre-selected range of services and virtual devices. So again, control and predictability, two choices two reasons why people choose on-prem or cloud.
Yeah.
So not to go back to the why people would choose cloud option, but like how much are you seeing, at least in the market today, where people are choosing cloud purely out of availability? standpoint? Like maybe they can't get GPUs, at a timely fashion that they need to start their process. And how easy is it to switch from one to the other if you've already started down the trajectory, right? Maybe, GPUs are going to come in for a few months. Is it easy to start and move back and forth? Are you seeing many people do that?
To address your first question, well, in essence, most people start with cloud these days. That's a common choice. Like I said, because of the challenges of skill set around making the right choice when it comes to picking the infrastructure for their workloads, but also the lead time that
Right, procurement, yeah.
procurement and lead time around the deployments. And to address your second question, how easy it would be to go back and fix things in the future, that would be heavily coming down to the workload design. Like in the classic days, we had IaaS, infrastructure as a service, and then PaaS, platform as a service. And we said that it's easy to move infrastructure as a service workload around, but at the same time, it's not the right peak to be in the cloud because you still have to manage it. And the same thing applies here, although the only difference is that I don't see many people doing infrastructure as a service for their AI workload. And the more you go towards platform as a service and SaaS, the harder it would be for you to shift around in the future. The reality is that AI also relies on lots of open source frameworks, tools such as TensorFlow's PyTorch. They can run in containers. You can't use Kubernetes. So the more you sort of lean towards open source, that would be easy to shift in the future.
I see. Yeah. Okay.
Yeah, that makes some sense. I've seen I was doing some work with Andrew Brown on his Gen AI boot camp that we're doing, or that he's doing, and I'm helping a little bit with very poorly. But yeah, I mean, he was showing me some of the open source tools, and where you pull a lot of the open source models and stuff like Llama Index and whatnot. But do you end up running these open source tools like you said, just run them as an app on Kubernetes? You build a Kubernetes cluster to run all these applications, and then in theory, Kubernetes is portable. You should be able to, if you wanted to run your cube on prem, then you could just move it essentially.
Yeah, that's the theory, right? And Kubernetes comes with its own. Speaking of Kubernetes, its own toolset around AI. They've got an MLOps toolbox, which I can't remember what something along the lines of Cube something. So they come with their own toolbox around AI. Obviously, there is just the choice of MLM frameworks, which most people tend to go to, either Keras or PyTorch or TensorFlow. So in theory, you can shift these things around, but for as long as you have the infrastructure to support that. And there is still some levels of lock-in with this CSP or that CSP that needs to be managed. But from a technical standpoint, there is opportunity to do that in the future if you have to do that.
Yeah, I mean, I think we've been talking about this on the show for a while now, is that there's a very strong difference between a company that's wanting to leverage, maybe specific things in the cloud to train their own models and do their own things versus someone that just wants to consume the off-the-shelf models that are relatively general purpose or use case focused, right? And I can see right there, like if you're consuming like an AI service or something like that, just to give an example, like if you're consuming AWS Bedrock for how you run your applications, moving that on-prem is not trivial, right? That's not just a lift and shift because you don't have that option. So I can totally see how the architecture design and kind of the adoption pattern is really going to matter whether or not you can move things around.
Absolutely.
if you build it yourself, obviously you have all the ability in the world to take that workload and move it back on-prem or from on-prem to cloud. But yeah,
Right.
with managed services like Bedrock, for example, I mean they've essentially built the infrastructure for you and then made it available to you like a managed service provider, right? So just like an MSP, it'd be a lot harder to take your workload and take your data and put that back on-prem.
All right. So yeah, let's move on to the kind of next topic we wanted to talk about, which is exactly what kind of infrastructure are we using for AI workloads. I'm assuming we want to focus more so on the kind of build your own, roll your own type of AI deployments. But what things go into choosing the specific workloads or choosing the specific infrastructure that we use for our AI workloads in cloud?
Sure, and they fall into classic infrastructure domains. There is storage, there is compute, memory, and networking. So I start with compute, and they come down into four main kinds. There is CPUs. They're good at handling general tasks and tasks that have sequential natures, such as I can start my job only after the previous job is finished, and that's by design. And CPUs are great at handling that. And that would apply to, again, most inferencing scenarios. Very, very few kinds of deep learning and neural networks that have sequential natures can be done by CPUs. And you would win if you use CPU over a GPU from a cost perspective. And the next would be GPUs. They are the most kinds, the most demanded. And again, the main value that GPU brings onto the table is that parallelism. They're great at handling parallel tasks. There is TPUs or tensor processing unit, which was a hardware that was built by Google to support tensor operations. And tensor operations are a subset of, or one type of math techniques that are used heavily in deep learning and neural networks. And there is also an NPU, which is neural processing unit. Same as GPUs and TPUs, good at handling parallel tasks, but they tend to be more energy efficient. Hence, their prime use case would be in edge AI, such as mobile and smart devices. From a memory point of view, and memory consumption comes down to different, constraints. There is, from a training point of view, the size of batch that you pick for the job drives your memory decision. Like I said, in the inferencing scenario that I described, you got to load a language model to the memory. So the larger the model, the more memory you need. And the more you need to think about, from a system design point of view, how you optimize that as well. But from a hardware point of view, DDR are still the most common affordable type that are great in working with CPUs, and then GPUs have their own DDR component, which is called GDDR. And there's been a relatively newer version, which has been around for 10 years, which is a high bandwidth memory, HBM. Again, that wasn't built specifically to support AI, but that's one of the options that provides ultra high bandwidth from a memory, a speed point of view. There is networking, and you guys know the drill here, so maybe we should swap roles, but there is a scale up and a scale out scenario there. With the scale up, I need some like a premium hardware which supports my model training, and that applies very well to small to medium-sized model training. But I want to distribute multiple jobs across different GPUs, but within one single physical node. I don't want to go over network. So in that case, I would rely on some special hardware that provides inner connectivities between GPUs and their memory components. There are two proprietary options that I know of. There is NVIDIA NVLink, and there is AMD something. I think something along the lines of Affinity. But realistically, for most jobs, you need to go over network. In other words, you need to distribute workload across different physical nodes. So the answer is ideally you need a combination of both. An awesome single node plus I need multiple of those. And to be able to go over the network, again, there is a proprietary option that provides that direct connections between GPUs across different nodes. There is InfInFAN, and there is an Ethernet version of that, which is called RoCE. Both of these techniques rely on a method called RDMA, or Remote Direct Memory Access, to offload some of the network management tasks from CPUs. So that's the added benefit. Of course, InfInFAN is a primary choice, and I think that's where Microsoft is using in their supercomputer that is used by OpenAI. But that RoCE tends to be more popular among network folks because of the familiarity and the skill set that they can retain from an Ethernet point of view.
Yeah, that's right.
Awesome.
And the storage tends to be the most agnostic of this from a workload perspective. We still need an object storage for flexibility. If we deal with lots of transactional data, then we're going to sort of fall back to hard disks and SSDs. So storage is less of a concern, but the question becomes how you communicate, how fast the storage can communicate with memory. And typically for hard disk and SSD, you would use SATA as the protocol. But there is a flavor of SSDs that use PCI Express, which tends to be faster exponentially over SATA, but that's only available to SSDs, and that's called NVM Express. Which is just basically SSD over PCI Express.
Right.
Yeah. It's really fast though. It feels like flash memory almost. Like it's pretty fast.
Yeah.
Yeah.
Well, yeah, that's great. Thanks for the breakdown there. I think it's relatively obvious that as you've gone through all of that it's not trivial to kind of put these things together, right? You need to actually be very focused and make sure that you're picking every right tool for the job here, especially when it comes to AI. I will say you have a note here that written down about confidential computing, and I will say I don't necessarily know if I know that term or what that really implies. So can we kind of break that down? What does confidential computing mean to you?
Sure. If you have heard of enclaves or CPU enclaves, that's basically what confidential computing is.
Gotcha.
It's about a piece of hardware which lives inside the CPU and can create workload isolation. Every time that data moves into enclave, it will be decrypted, and every time that it gets out of enclave, it will be encrypted. So that will provide that encryption or data protection in move to complete the life cycle of data at rest and data.
Data in transit. Yeah. That makes sense.
Yeah.
How important is that? How important is that process? Like when it's all within, I guess, within an application or within a network that's under your jurisdiction. Is that as important? We talk about going over third-party mediums, that's obviously, I can see a strong use case for requiring encryption there. But are we seeing a lot of that within, fully contained environments?
Yeah, one of the benefits obviously is that except for the application code, which again will be authorized to access that piece of sensitive data, no one else, and that's the advertised benefits. No one else can access data, even the cloud service provider. So that would help organizations to sort of, go through their own hurdles and establish controls when it comes to cloud. Because again, this is less about how secure cloud is, but is more about how much control you've got
Right.
from a customer perspective over cloud. And that would help ticking that box or facilitate some of those activities from the customer side. There are some strictly regulated industries such as military, which aren't comfortable as much to be on the cloud. And they are reluctant to go through that because there's a lot of work to sort of go through those hoops and tick those they may not have resources or a skill set or cost to finish that process. So they decide to stay on-prem. So things such as confidential computing, which is not, again, unique to AI, but it's more around data protection and compliance, would help those organizations sway towards the cloud option as opposed to the on-prem. So it's more about a control thing than security thing, at least from my perspective.
All right. Yeah. Thanks for breaking that down for us. That's really good. So obviously, Sam, you work for a research group, right? So probably a lot of analysis goes into this, and we will look at where things are trending, what's going to happen in the future, right? So I guess at least from what you've seen in the market today, what do you feel are going to be probably the most prominent challenges people are going to have, and what's in store for the future?
Sure. And again, this is a fluid topic, so I can only speak to the decisions that people have made in the past. But first thing is, I think I touched on it before, from a cloud versus on-prem. Most people still choosing cloud because it's convenient. They need a whole bunch of tools, and cloud is fairly attractive from that perspective. So that's one. From a hardware point of view, I think one of the challenges that I've observed is supply bottleneck or supply challenges, and it may vary from market to market. Obviously, some markets such as North America or Europe might be more aggressive when it comes to AI, so therefore the type of challenges around that would be different to other markets, but also some availability issues might exist in a market like Australia or APAC compared to the US. So there might be some lagging, but that still remain to be the challenge in the next year or so. And as you might know, NVIDIA has partnership with all 4 to 5 CSPs, major CSPs that we know of.
Yep.
But new players are coming in. Like last year, during the Insights event, Microsoft announced their partnership with AMD, which is good news. And other players are coming into that GPU manufacturing. So it's no longer just NVIDIA, and that might alleviate some of those pain points. But something that comes off the back of supply issue is cost. Obviously, the typical supply demand. The lower the supply, the higher the cost. But what I think will add to that is the fact that we need muscle resources for HPC. They are not usual, so these will add extra price tags to what we're dealing with. But I think that should be remediated in the future, and I wouldn't be surprised that some of the cloud cost or operational cost to come down as well. The more abundance we get, that the more the less hostile it's going to get from a point of procurement and provisioning perspective. And
I'm
the
looking forward
last
to
thing
that.
is optimization. Optimization is still a challenge, and with DeepSeek, that was a very good lesson learned. Like I myself always thought that OpenAI is gonna make the best choices when it comes to that. It took about, and this is from Forbes, but also anecdotes, between 40 mil to 80 mil just to train GPT-4 model, just to train that. And with Gemini, again, the range is wide. They mentioned somewhere between 40 mil to 190 mil. Again, that's a wide range. But this is the ballpark figures, and I think the deep seek has changed a lot of that. It's going to change a lot of that. But I think there is tons of opportunities to optimize.
Yeah.
If you take a top-down approach as opposed to a bottom-up approach, and by which I mean start from use cases and then break it up and take a divide and conquer approach to decouple different types of workloads and then move your way down from that point.
Yeah, it makes sense. I mean, it's just a natural thing that we need to be able to do that, right? I'm just thinking back to, the days when, initially when we started storing data, you needed like 4 life-size cabinets of storage to house like 500 kilobytes, right?
Like ENIAC,
yeah. Now it fits in, kind of like the fraction of my pinky nail to do that, right? So it's like, it's natural that optimization needs to occur. And yeah, I mean, not to timestamp this episode too much, but this is, as Sam pointed out, this is only 2 days after the DeepSeek model has launched. So by the time we release this episode, I don't know if some significant amount of data would have come out about that. But it's I agree with you there. Optimization needs to be in the forefront of this. And I mean, I would think like obviously the vendors are going to potentially sell less hardware components, so the more things optimize. But I think that's kind of the natural lay of the land. That's what we need in turn.
I actually don't know about that. Like, think about it. If this stuff was easier to run, sorry, I didn't mean to cut you off though, but if this stuff was easier to run, like it was a lower cost of entry, I think we'd actually see more hardware because more people would need it. More people would be trying to build their own data centers to run it. Like in theory,
maybe I'm just thinking in terms of quantity, right? Obviously, if you can do the same job with a fraction of the GPUs, then in turn I'm going to sell less GPUs to that one specific customer.
Oh, per customer, sure.
Yeah, but yeah, to your point, adoption is key, right? It's how many people are actually doing it. So so it's kind of it's a balance, right?
I still don't think we need $100 or $500 billion to be invested in, AI or whatever it is. I think that's a huge grift, and I think I'm curious to see what things like DeepSeek keep showing, because I mean other countries are working on this too. It's not just China. There's other people out there working on this, and I'm curious to see. The timing on that was not a surprise either. Right after Project Stargate, whatever, we're going $500 billion. The next day, China is just like, whoop. Oh, look, I slipped and dropped my open source LLM on the market.
Yeah, absolutely. Thanks a lot, Sam, for coming on. I think we'll go ahead and start wrapping up here. So last thing, any closing thoughts that you want to add about the episode today?
No, I think I just formulated my final thoughts in that last question around the stats. But if you have any, you can throw it in.
No, sounds good. Like I said, I think we're all eager. We understand this is a very ephemeral environment right now, right?
Changing
Whether
pretty
it
quick.
be, whether it be the technology or it be the, the roller coaster that is the Nvidia stock price, et cetera. Things are changing literally every single day. So, well, Sam, thanks for reaching out and thanks for coming on the show. I think this has been informative. So, if people want to reach out and talk about any of this stuff, how can they reach out to you?
You can hit me up on my LinkedIn, Sam Zamanian, and that's a primary channel for a lot of people to reach out for.
Awesome.
For lots of folks.
Perfect. Sounds great. Well, I'll make sure we get that into the show notes. So if you want to reach out to Sam, please check that. And so thank you so much for listening. This has been another episode of the Cables to Clouds podcast, and we will see you next week. Goodbye.
Hi everyone, it's Tim, and this has been the Cables to Clouds podcast. Thanks for tuning in today. If you enjoyed our show, please subscribe to us in your favorite podcast catcher, as well as subscribe and turn on notifications for our YouTube channel to be notified of all our new episodes. Follow us on socials at Cables2Clouds. You can also visit our website for all the show notes at cables2clouds.com. Thanks again for listening, and see you next time.